Here we have an optimization problem. Find two numbers whose sum is 20 and whose product is maximized. We're going to follow this outline to answer this question. Step one, we're going to name the quantity that we want to optimize. In this case, we want to maximize. Step two, we're going to write an equation that relates this variable from step one to only one other variable. Step three, we're going to find the first derivative and the critical number. Step 4, which is probably one of the hardest steps, find the absolute minimum or maximum as required. And then step 5, we're going to wrap it up with a conclusion. So in this problem, we're asked to find two numbers. And let's begin step 1. Name the quantity to be optimized. We'll let x and y be the numbers we seek and let p equal the product. They want the product to be maximum. So P equals the product that we want to maximize. Step 2, write an equation relating this variable P with only one other. Well, we know that P equals X times Y, but we need to eliminate one of those variables. We can only have two variables here. So in order to eliminate Y, we'll use a relationship between X and Y. Specifically, the given information said X plus Y equals 20. Solve that equation for y and substitute it into the product. P equals x times parenthesis 20 minus x. Go ahead and distribute the x to get 20x minus x squared. Now find the first derivative of p. P prime of x is 20 minus 2x. And that happens to be a polynomial, so there are only roots for a polynomial. Only the roots will be critical numbers. There are no values x for which the function will be undefined. So you find the zeros, which will be the critical numbers, by setting the derivative equal to 0 and solving. 20 minus 2x equals 0. So 2 parenthesis 10 minus x, we factored it, equals 0. Set each of the factors equal to 0, we get x equals 10. That's our one and only critical number. Step 4, find the absolute minimum or maximum. We're only interested in the maximum here. Polynomial p of x equals x times y, which we changed to 20x minus x squared, implies that, well, it's continuous everywhere. So we can use note 93. In note 93, we're going to consider a critical number, which in this case we found to be, in the previous step, x equals 10. Now p of x, which we told you was equal to 20x minus x squared in step 2, that implies that p prime of x is 20 minus 2x, which factors as 2 times 10 minus x. We already know that. Thus, we see that when you set the derivative of p greater than 0, that occurs, that the second derivative, the first derivative is greater than 0 when x is smaller than 10. Just look at p prime of x and you'll see that. And p prime of x will be smaller than 0 when x is greater than 10. So what do we see? We see that we have an absolute maximum at x equals 10, according to note 93. And this is just from a careful observation of the factored form of p prime of x using note 93. Thus, our conclusion is that the first number will be x equals 10, and the second number will be, well, let's substitute x equal 10 into the given x plus y equals 20. We get y equals 20 minus x, plug in x equals 10, y equals 20 minus 10, y equals 10.